Hi Year 12. Today's video is relating to 1G and we're going to be summing a geometric series. There are two formulas that we have for the sum of a geometric series. They are both on your HSC formula sheet, but you need to know when to use each one. Just like our AP, they relate to the letter S, S for sum, and it has a subtext here, N, and that just relates for the sum to how many terms. Now, the formula that we use will depend on whether our common ratio, which is R, is less than 1 or whether it is greater than 1. If it is less than 1, then our R becomes after our 1, and it's A times 1 minus R to the N all over 1 minus R. And if our R, or our common ratio, is greater than 1, then it sits before the 1, and it becomes R to the N minus 1 all over R minus 1. Here is the first page of our HSC formula sheet. So under sequence and series, like we've been looking at, our two formulas for today sit there as well. And they're just down here. So you can see the pattern now that we've got our two AP formulas followed by our two GP formulas. The difference being here is we do not get told when to use each of those formulas. So this one would be for R less than 1, this would be for R greater than 1, and note R cannot be equal to 1 because we'd have a bottom line of 0 and we cannot divide by 0. So make sure you're always checking your sheet for that formula. So we're going to have a look at the first example, 1A, and it would like us to find the sum of all the powers of 5 from 5 to the power of 0 to 5 to the power of 7. So the key word there is sum. So you need to note that and know that that's telling us find the sum of those numbers. We need to know what information that we already do have. So what do we have? Well, we know our first term, A, is going to be 5 to the power of 0, which is equal to 1. And our common ratio, we're in the GP topic, so normally we would test that it is a GP. I'm going to tell you in this case that it is a GP, but we can still test that term 2 divided by term 1 is our ratio, which would be 5 to the 1 divided by 5 to the 0, which is 5. And if we wanted to test it, if we didn't know it was a GP, we'd test then that 5 to the, oops, that should be a 2 down there, sorry, term 3 on term 2. That 5 to the 2 on 5 to the 1, which is 5 fives, which is 25 divided by 5, which is 5. So there we are. Our common ratio is going to be 5. So in this case, because our R is greater than 1, the formula we want to use to sum there is A times R to the N minus 1 all over R minus 1. So our sum is going to be our first term, which is 1, times by R to the N. Now our R is 5. And now we need to figure out, well, how many terms have we got? We've got terms from 0 all the way to 7. So 0, 1, 2, 3, 4, 5, 6, and 7. We have 8 terms. So we're summing to 8. So our R is to the power of 8 minus 1 all over R minus 1, which is equal to 4. So our sum to 8 terms is going to be 5 to the 1 minus 1 over 4. So pop 5 to the 8 on your calculator, minus 1. I might just pop it up here on my screen. Which is going to give us 97,656. Okay, so part B, or question B, wants us to find the sum of the first 6 terms of this geometric series. So it's told us it's geometric, so we don't need to test it. Our first term is 2. Our common ratio, we're going to just grab our second term and divide it by our first term, which is minus 6 divided by 2, which is minus 3. If you needed to test that, you could still test your 18 divided by minus 6, which is still going to be minus 3. And in this case, our R is less than 1, so the formula that we're going to use is the first one. So I've just written down the formula that we're using there. It's asking for the sum of the first 6 terms, so it's sum to 6. Our A is 2. It's going to be 1 minus our ratio, which is minus 3. And it's the whole of that minus 3 to the power of 6, so just be careful there. And that's going to be 1 minus our ratio, which is minus 3. So our sum to 6, neatened up, will become 2 times 1 minus minus 3 to the 6, all over 4. Pop that in your calculator and we'll see what that sum is. It is minus 364. Let's look at question 2. Question 2 says the sum of the first 4 terms of a GP with ratio 3 is 200. Find the first 4 terms. So you need to think what the question is asking you and write that down. So the sum of the first 4 terms, so that would be S to 4, of a GP, so we know it's a GP, the ratio is 3, and it's saying the sum of those first 4 terms is 200. So we need to think about which formula we would use, because we are looking at the sum, we don't have the terms, so we want one of those 2 sum formulas up above. Our R is greater than 1, so the formula that we want to use is sum to n, A, R to the n minus 1, all over R minus 1. Let's put in what we know. That sum to 4, which is A, times 3 to the 4 minus 1, all over 3 minus 1, is equal to 200. So that would mean that A times 3 to the 4 minus 1 all over 2 equals 200. Neatening that up, A times 3 to the 4 minus 1 equals 400. I've just times by the 2 that's on the bottom. So A is going to be 400 divided by 3 to the 4 minus 1, which is going to be equal to 5. So now we have enough information to work out what the first 4 terms are. We know our ratio is 3 and our first term is 5. So our first term would be 5, and we're going to be increasing by a factor of 3. So we're going to be timesing by 3. 45 and then 135. And that is our sequence there. Let's look at question 3a. It says find a formula for the sum of the first n terms of this GP. So with this one, we don't know how many terms we want to go to. We want a generic formula. So we know it's a GP, and we know that our first term is 2. And because they've told us that it is a GP, I don't need to test to find the common ratio. I can just pick out, for example, term 2 and term 1 and divide them and get 6 on 2 is 3, which would be the same as if I divided 18 by 6. I'd also be equal to 3. So I here have my ratio being greater than 1. So the sum of a GP would be given as A times R to the n minus 1 all over R minus 1 in this case. I'm just going to pop in the information that I have. Sum to n is going to be 2 times by my ratio, which is 3. I don't have an n, that's minus 1, and it's all going to be over 3 minus 1, which is 2. So if this bottom line becomes a 2, and it cancels with my 2 on the top, my generic term for the sum is going to be 3 to the power of n, take away 1. Let's have a look at how else they could ask a question like this. This one's saying how many terms of the GP. So when we're looking at the number of terms, what we want to do is we want to find our n. So how many terms of this GP must be taken, and when they're talking about this GP, they're talking about the one up above, so it probably should have said hence in that question. How many terms of this GP must be taken for the sum to exceed 1 billion? So we want our sum to the power of whatever n it's going to be greater than 1 times 10 to the power of 9, or 1 billion. So we have our sum to the n being 3 to the n minus 1, and we want that to be bigger than 1 billion. So what we need to solve here is for the value n. N is in our power. So we have a lot of difficulties in solving things that are in the power. And generally what we do to remove this thing from our power is we use a logarithm. So I'm going to use a logarithm in this question. But what I'm going to do is get rid of this minus 1 and add 1 to both sides. So I end up with 3 to the n is greater than 1 times 10 to the 9 plus 1. So I've added 1 to the left, I've added 1 to the right. And to make that a little bit nicer, I'm going to write that as 3 to the n is going to be greater than 10 to the 9 plus 1. Now, if you're not comfortable with the 10 to the 9, you can write that as a billion, okay? And it's going to be 1 billion and 1. So you can write that if you don't like the 10 to the 9. But what I need to do is I need to take the log of both sides. Now, I think this is going to be the easiest way to do this in this question because we have this inequality. I don't want to write it in the format of a log straight up. I want to take that log of both sides. So let's do that. It's going to be the natural log, base e. I don't need to do anything with my inequality sign because I haven't divided or multiplied by a negative. But I have now got a log law that I can use to bring this n down to the front. And that is why I have taken the log. And that is why we use the log, because of that log law. So whenever you have a power up in the air that is unknown, you generally, most of the time, are going to need to use logarithms to get that down the front. And now I have this n down the front. I can divide by log base e of 3 on both sides, and I'm going to have an n on the left-hand side all by itself. So log of base e of 10 to the 9 plus 1 all over log of base e of 3. These are values now that you can pop on your calculator. So I want you to pop that in, and what you're going to end up with is a value of n of 18.863. So that's how I popped it in my calculator if you want to have a look at that. And I've ended up with n being greater than 18.863. And what our question said was how many terms of this GP must be taken for that sum to exceed 1 billion. So n must be greater than 18.863. We can't have a partial n because remember n is the position of each of our terms. So n must be greater than 18.863 and there's a few values after that. So n must be 19. So answering their question, 19 terms must be taken to exceed 1 billion for the sum.